Good day, everyone. Welcome to our today's class. In this class, we want to look at pulse width modulation. Pulse width modulation is a method of controlling the average voltage passing through a component, and it is a stream of voltage pulses that reduces the electric power supplied by the electrical signal. And the effective voltage is controlled by the width of individual pulses in a stream of voltage pulses of a pulse width modulation signal. So in this class, we want to use two buttons to increase or decrease the voltage passing through a component, and the component we want to use is a LED and also a DC fan. Now, in our first line of code, we attach the decrease button to pin 2, while the increase button is attached to pin 8. The LED is attached to pin 13. In our void setup, the decrease button, of course, is an input. The increase button is also an input, and our LED as well is an output. In between the setup and the void loop, there is an initialized variable called LED brightness. This LED brightness is the one that is going to store the status of the LED or the fan or the component that we want to vary the voltage that is passing through it. So initially we are assigning 128 value to it. Now let's get something right here. There is difference between digital value and analog value. The digital value or digital signal is either low or high, or let me say off or on, or 0 or 1. Those are digital signal. But when it comes to analog varies from 0 to 225 when we are talking about analog. In this case, varies from 0 to 225. In our void loop, we said if the decrease button is pressed, that is if it is low, you should increase the voltage that is going into that component, which is the LED. Else, if the increase button is pressed, you should increase. This plus simply means increase, while this minus simply means decrease. So if the increase button is pressed, you should reduce the voltage that is going into the component. At this segment, we want to pass the voltage that is coming from the pin, which is the pin 2 and pin 8. We want to constrain it to 0 to 225, meaning it will convert the signal voltage coming from those pins to analog. So it now varies from 0 to 225. Now the half of 225 is 127.5, but we round it up to 128. Now we now say LED brightness is equal to constraint. This constraint is a key word. Constrain the value coming from this LED brightness to 0 to 225. So the value will be from 0 to 225. After that, we now say analog write. So analog write LED pin, that is analog write to LED pin, the value that is inside this LED brightness, which is from 0 to 225. So this simply means that the initial stage of that LED or fan or anything you attach to that pin 128, but when you now increase or you decrease, the value will now increase or decrease between 0 and 225. Let's look at the simulation. In this design, I want to add a DC fan to it so that we can see the effect of the pulse width modulation signal. So just attach it to the pin 13 and attach the second terminal of the fan to the ground. Now run your simulation. You see that the brightness of this LED is varying. Also, this motor as well, the speed is somehow slow, or let me say average. If you press the increase button, it's going to increase the brightness of the LED, and also the movement of the fan is going to increase as well. So as well, if you press the decrease button as well is going to reduce the brightness of the LED and also the movement of the fan until it gets to 0. So once it gets to 0, it's going to off it, and this fan too is going to stop after some time. So if you increase it, the LED is going to on, and the brightness will keep increasing, and the motor is going to be faster compared to when it is low or when it is off. So let's try this and see how it works. Bye for now, and meet you in the next class.